Hello and welcome to another video. In this video, we're going to be doing the hard problem of the 375 contest, which is count number of good partitions. And in this problem, you're given a zero-index array nums consisting of positive integers. A partition of an array is one or more contiguous subarrays is called good if no two subarrays contain the same number. Return the total number of good partitions of nums. Since it's big, return it modulo 10 nums plus 7. So for 1, 2, 3, 4, they have all these partitions. We can have 1, 2, 3, 4 separated. We can have 3 and 4 together. We can have 2 and 3 together. 2, 3, 4, 1, 2, 3, 4 separated. This, like all of these things. Then for 1, 1, 1, 1, the only possible good partition is all of it. So notice that this right here is the key part of this question. So good if no two subarrays contain the same number, meaning if there is a number multiple times, that whole chunk has to be in one array. So because there's a 1 multiple times, that whole chunk has to be in one array. Similarly here, 1, 2, 1, 3, this whole chunk has to be in one array, and you can't do anything about it, right? Similarly, let's say if we get 1, 2, 1, 2. Well, now we know 1, 2, like this part has to be in one array, and this part has to be in one array. So the only way for that to happen is actually for these to be combined. And also, if you notice, like let's say these these indices are like 0, 1, 2, 3. If we actually draw them out as intervals, so for 1, it starts at 0 and ends at 2. And for 2, it starts at 1 and ends at 3. Notice these overlap. So anytime you have intervals that overlap, you're also going to have to combine those into one interval. And so this is basically a merge intervals problem. So let's take a look at a bigger one of these. And here we go. So what we are going to do is for every single number, we will write where does it start and where does it end. Because for a number like 1, if it starts here and ends here, that means this whole subarray, at the bare minimum, this whole subarray has to be in one chunk, right? So we're going to do this for every single number. So let's say for 1, it starts at index 0 and it ends at index 6. And you can easily do this using like a dictionary or something, you know. So yeah, you can use a dictionary. Actually, nice thing is you can actually just do a one-pass dictionary where you just maintain a start and an index. And the way that's going to happen is if your number wasn't in here, your start and end will be the same. So for example, here I'll just be like 0, 0. And if your number was in here, you just update your end index. And in Python, dictionaries are ordered, so this is going to be sorted by the insert. So that way, when you go and merge your intervals, your keys will be sorted by smallest index first. If you don't want to do that, you can also just do a one pass, record the end index for all of them, and then do a second pass. And anytime you run into a number, just say it starts here, and use the end index from the dictionary. Like that part's not hard. So anyway, so let's just go through this. So 1 is going to start at 0, and where's the last occurrence of it? It's at index 6. So that's going to be 1. Now let's keep going. So for 2, it's going to start at 1. Last occurrence is at 1. For 3, it's going to start at 2. And obviously this can skip some numbers. So like this doesn't have to have every single number. I just do it this way. So 3 starts at index 2 and goes until index 13. So let's draw that. And 4 starts at index 9 and goes until 12. So like this. And what else do we have? So we have 5 starts at index 4 and goes until 10. And 6 starts at index 5 and ends at index 5. 5, 5. And I think the last number is 8. So 8 is 11 and 11. So here we have it. And like I said, in Python, this is ordered. So you can just then take all your values and put them into an array. So now this is a merge intervals problem, right? So let's just draw out our intervals. So we have 0, 6 and 1, 1. So 0, 6 and 1, 1, we will immediately merge. Like those have to merge. So obviously just a simple merge intervals problem. So the start index is going to be the smaller one and the end index will be the bigger one. So 1, 1 will just go into 0, 6. So we can delete 1, 1. Then the next one is 2 and 13. And so there's an overlap here, so we have to merge these as well. So this is going to go 0, 13, overlap as well. Can get rid of all that. Then the next one is 9, 12, which will just go straight into 0, 13, right? So if we have 9, 12 as the next one, this will just go straight into this. Then 4, 10 will also go straight into this. 5, 5 will also go straight into this. And finally 11, 11 will also go straight to this. So really here we have one interval, which means like how many different arrays we can have. Well, the number of intervals is really, you can just rewrite. So let's say you have some number of intervals that you can treat those as separate items in an array. So this is the same thing as just doing something like this, right? We can just count up. We don't really care what intervals we have, just to count. So we did a basic merge intervals. We know we have one interval, and how many ways can we write this? Well, this is obviously just one, right? So that's going to be how we do it. But what about if there isn't one interval, right? And so this is now the next part of this problem is just going to be like we figured out how to condense this into how many intervals we actually have, and that's going to be the like every array has to be divided into this, and we can combine stuff further, right? So let's say our intervals were like 1, 1, 2, 2, 3, 3, and so on, right? We had a bunch of these. Like I said, we can rewrite this as just 1, 2, 3. So let's say we have like 1, 2, 3. How many different ways can we basically split this up now? So you can figure this out recursively, and that's going to be the easiest way to do a lot of these combinations problems, like how many intervals can you break it down into. So let's just say we have 2 intervals. Like let's just say we have like 1 and 2. Well, we can either combine them or they can be separate. So there's 2 ways, right? Now let's say we have 1, 2, 3. And we can break this down into like a recursive case. So we can take 3 by itself, right? 3 by itself, and whatever the result of 1 and 2 is, which is, as we know, it is combined or separate. And because we have to maintain this order, right? Because we have to maintain the order of 1, 2, then 3, no matter how we divide it, like these subarrays have to be in the same order. We don't have to worry about like combinations. So we can just take the subproblem of this is 1 and 2. Now if we have 3, this can either be separate or it can be combined. So because there's 2 here, we can either have separate or combined, so we'll have 2 more. And that's correct, right? So it'll be like this, 1, 2, let's say it combined first. So with a 3, then we'll have 1, 2, and 3. That'll be combined. Remember, we can't combine 1 and the 3 and have 2 apart because we have to maintain order. Now we can show 3 separate. So it'll be like 1 and 2 combined, then 3 separate. And we can also do 1, 2, 3, right? And so if we added 4, let's say if we had like 1, 2, 3, 4 in our array, then it's going to be the same thing. It's going to be 4 combined with whatever you can do with 1, 2, 3, which is going to be all these things. So it's going to be like this. Well, it's actually, we can even write it, right? So we can even just do this. So this will either be with 4 combined, right? Where the idea is like, for example, with this, you'll just add a 4 into here. You'll add a 4 into here. You'll add a 4 into here. You'll add a 4 into here, right? That's combined. And then you can also have this same thing again, right? This exact same thing separate, right, from 4. So this will be separate. Which will mean like you'll have 1, 2, 3, and then 4 will be by itself. 1, 2, 3, 4 will be by itself, and so on. So essentially, every time you add a number, you double what you had before, right? Because combined and separate is 2. And then how many different ways could we have this? We could have 4. So if we have 4 numbers, so 1, 2, 3, 4, we can just try to see if we can get a pattern. So if we get we get 4 times 2, so we get 8 combinations, right? If we get 1, 2, 3, we already did this here. This was 4 combinations. If we have 1, 2, we have 2 combinations, and if we have 1, we have 1 combination. So now you can see that like it's just doubles, right? So you just take your length of your, like let's say you have 4 intervals here, or let's look at this one, right? So we have 1 interval goes to 1, 2 intervals goes to 2, 3 intervals goes to 4. So this is just if n is the number of intervals, then combinations equals 2 to the n minus 1, right? So if n is one interval, you'll have 2 to the 0, which is 1. If you have two intervals, 2 to the 1, which is 2. 3 intervals, 2 to the 2, which is 4, and so on. So that's kind of the crux of this problem is we first take all of our numbers, get a start and end index, make these intervals. Then we have to combine every interval because if we have intervals we have to merge every interval that has an overlap, right? Because if we have an interval like this and we have some other interval like this, then like these can't be separate because there's an intersection. So anytime there's intersection, we merge, and then whatever intervals don't intersect, we just figure out how many are there, and then from there we can just get a basic number of combinations, just get the intervals and get this equation. And that's pretty much it. So now we can code it up. So for this one, actually, this is one of the hard ones that the code is pretty easy. So we're just going to have locations, and we can just enumerate through our array. Enumerate. And we're just going to check, have we seen this before, right? Like I said before, in Python, you already have an ordered dict. In another language, you can do a two-pass. Your first pass will just get the last index of every number, and then your second pass can get the first index of every number, and then you just make the intervals that way. So if v is in there, then we just need to update the, remember our dictionary is going to have a start index and an end index. We just need to update the end index. And if it's not in there, then we can just say that the start index and the end index is the same, right? So if we see like 1 at index 0, that means the start index of 1 will be 0, 0. Or the start index of 1 will be 0, the end index will be 0, and then anytime we see it again, we'll just update the end index. And at the end index will be the last time we saw it. Now we have to make our intervals, so we just say intervals. We can actually probably make a list comprehension, might as well, right? So intervals equals list comprehension, and this is going to be val for val in this dictionary dot values. Right? So take every single tuple, or not tuple, array, and because this is in the order that they were inserted in, the items that were inserted at the smaller index will be there first. So this will work. So we get our intervals, now we just merge our intervals, so pretty straightforward merge intervals. So we can just like have a result equals 0. We can have our current end of the interval be -infinity. And then we can just go through our intervals and compare if there's an overlap. If there is no overlap, add the interval and change it. And if there is an overlap, then figure out like what that new combined interval should be. So the reason I have this is just because if we don't do it that way, we're going to have an interval left over that we have to add. This way, we're going to take care of that interval right away, right? So we're going to insert like an imaginary interval, and then the one we have left over, we don't have to add at the end because the count will be fine. So now we just have to loop through our intervals. So for start and in intervals. And so if start is greater than cur, that means there is no overlap, so we can add an interval. And we are going to make our new cur the end of the interval. Otherwise, there's going to be an overlap here, and so if there's an overlap, start is we only care about the end because we know that the start of our current interval is always going to be smaller or equal to the next one because they're ordered by start, right? That's the other thing. We didn't need to sort our intervals because we have this dictionary that is in order, or you can do a two-pass so you can avoid sorting your intervals. They will already be sorted. So yeah, otherwise we just have cur equals max of the cur and the start will automatically not matter. So we just take whatever interval, whatever the biggest end value is, save that for our merge. Now we have some number for our interval, so we can actually print intervals if we want to even. So we can say like print intervals and like return something just to show this. So like return 0 for now. If we actually run this and we take a look, here are our intervals. So 1 starts at 0, ends at 0. 2 starts at 1, ends at 1. 3 ends at 2, ends at 2, and so on. For something like this, we only have one interval. For this, 1 starts at 0, 2, 1, 1, 3, 3. So these two would get merged. You'd have 2 total, and so on. So good to demonstrate that. What did I just do? Okay, there we go. So finally, we can just return, instead of printing here, we can just return remember, the equation we need is we need to also mod it by mod. So yeah, because they say it's too big. So we can put all this into here. So we're going to do 2 to the power of intervals minus 1, right? However intervals we have minus 1, that was our equation. And then we can insert a mod value here, so we can just insert 10 to the 9 plus 7. Or you could just do a normal exponent and mod it yourself. This is fine too. But this takes care of it for you. You can insert an optional mod value, return it. There we go. Okay. And yeah, you can see pretty efficient, pretty fast. So let's think of the time and space for this one. So the first thing we do is we do a one pass through our nums, so O of n. Second thing we do, we go through all of our values and we make an interval. So that's also O of n, because you can't have more values than numbers. So that's O of n. Then we merge our intervals. Because our intervals are already sorted, that's also O of n. We're just looping through them once. And finally, we calculate this like power thing, which is technically O of log n, but that's going to be less than O of n. So that's just this. So now for the space. So for locations, that's O of n. All right, we have to make these intervals, and worst case scenario, every number is unique. So that's going to be O of n. So locations is O of n. Intervals is O of n. Yeah, and that's all we use. So yeah, definitely an easier hard weekly contest problem. Nothing insane in this one. Still kind of hard to get the gist that you have to do this intervals, but once you understand that, like, okay, if I have a number that appears multiple times, then it needs to, like, that entire subarray needs to be in my subarrays, and I need to basically take care of all overlaps and have non-overlapping intervals. And then from there, also, you do need to figure out, like, if I do have this, how many possible combinations can I make? But like I say, I think for almost all of these, whenever you're looking for combinations, if it's not just like a direct n choose k, just kind of see if you can get a pattern. Like, start with a few numbers and see if you can get a pattern. And usually you get a pattern pretty quick, and then from there you can just make an equation. So yeah, that's going to be all for this one. Hopefully it was helpful. Last one for this weekly contest. And if you did like this video, please like it, and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.